Welcome to NALLA NARASIMHA REDDY Education Society's group of institutions integrated campus. Structural Engineering 1 Reinforcement Cement Concrete RCC. I'm Dr. A. Mahesh Babu, Professor, Department of Civil Engineering. In last videos, I explained about different type of structures, materials. In this video, we will see concepts of RCC design. See, this is very important. What is the concept in the design of RCC? First of all, we'll define concrete. What is concrete? It is a mixture of sand, aggregates, cement, water. If you mix together all and you can pour into in the form of required shape and dimension, and you will get desired structure. That is, concrete is a stone like substance obtained by permitting a carefully proportioned mixture of, that is, proportion is very important. 1:2:4, 1:1.5:3. That is proportional. So that cement, sand, and gravel, appropriate proportion is required. And aggregates, other aggregates, and with water to harden in the form of the shape and dimension of the desired structure. Plain cement concrete is a hardened mass obtained from the mixture of cement, sand, gravel, and water in the defined proportion. What is plain cement concrete? A plain cement concrete is a hardened mass obtained from a mixture of cement, sand, gravel, and water in defined proportion. See, these ingredients are mixed together to form a plastic mass. Which is poured into desired shape. Suppose if you want column, in column shape, footings, foundation, columns, beams, slabs, whatever may be your structural element, these plain cement concrete are mixed together to form a plastic mass, and this mixture is poured into desired shape molds, I-forms. This plastic mass hardens, and on setting, and we get plain cement concrete. How we will get plain cement concrete? By mixing of all this cement, sand, gravel in the required proportion and mixed with water to form a plastic mass, and that is poured into desired shapes. That plastic mass hardens on settings, and that we will get plain cement concrete. The hardening of this mixture is caused by a chemical reaction between cement and water. See how you are going to get hardening. This is nothing but chemical reaction between the cement and water, mixing with your sand and aggregates. See, these are very important points. Plain cement concrete has good compressive strength, but very little tensile strength. See, this is one of the important points in the RCC concept. Plain cement concrete has good compressive strength, but very little tensile strength. The plain cement concrete structural element will not fail due to compressive load, but it may fail due to tensile strength. That is limiting use in the construction. That's why you won't use only plain cement concrete. Okay, why? Because it will failure occurs in the plain cement concrete due to its low tensile strength. See, still research is going on. If you get tensile strength with plain cement concrete, you can go for small 1 feet, 2 feet, like that. You can have this shape of structures you can use, but for when length is more, the plain cement concrete will fail due to its low tensile strength. Plain concrete used where good compressive strength and weight are main requirements and tensile strength are very low. See, where we are going to use this plain cement concrete, for example, in pavements. In pavement, generally you will have compressive loads. The compressive strength will take care by your plain cement concrete, and certain dams where mass concrete, mass material is required. Reinforced cement concrete is strong in compression and weak in only not reinforcement, only concrete. When concrete, say, if you look at concrete, concrete is a brittle material, strong in compression but weak in tension. So that's why steel used inside concrete for strengthening and reinforcing the tensile strength of concrete. So this will be repeated again in behavioral material. So this is very important point. Why we are going to provide steel in the inside concrete? As the plain cement concrete is weak in tension, so steel is used inside the concrete for strengthening and reinforcing the tensile strength of concrete. This steel must be appropriate deformation to provide strong bond interlocking of both material. When completely surrounded by the hardening concrete mass, it forms a integral part of two material known as reinforced cement concrete. So steel is very strong in tensile strength. See, once again you see this video to understand the concept of RCC.
G'day, welcome back to BuildSim. What I want to show you today in this video is the strength and weakness of concrete and steel and how we use them together as reinforced concrete to provide or to form a very strong structural member of our building. So essentially, this is our slab of concrete, and concrete is very strong when it's compressed or pushed together. So think about a force being pushed along the line of these arrows, pushing the concrete together. The concrete's going to stand up pretty well. It's not going to want to crack or anything.
Plain cement is subjected to compressive stresses.
And it's very strong in compression. However, if we were to reverse the situation and try and pull...
This is subjected to tensile stresses or forces.
Concrete apart, then the concrete's going to break reasonably easy. So concrete is very strong in compression, very weak in tension. Steel, like our reinforcing rod, however, is the opposite. It is incredibly strong in tension. So think about tug of war with a steel rod. Even if you tied two cars to the rod, you need a fair bit of force to cause any damage to the rod. So steel is very strong in tension. However, if we were to try and compress it, it would very quickly deform and buckle and get out of shape. So steel has the exact opposite properties as our concrete. So that's why we can form them together. But the thing is, our concrete slab is just sitting there. How is it ever going to be placed under compression or tension? So what happens, especially with suspended slabs, if the slab's supported on both ends, such as this one, and then there's a load placed in the middle, and that could be the self-weight of the concrete or any live loads or dead loads that you're going to put on top of it, then what is effectively what's trying to happen is that the slab is being pushed or trying to be pushed into that shape. So what that does is, because it's now a concave shape, the top of the slab has actually been compressed by the load, and the bottom half of the slab is now in tension because it's actually been made longer. So this is where the structural engineers come into play, and this is how they work out where they're going to place their reinforcement. So we need to place reinforcement in the areas of the slab that are going to be placed under tension. So in this case, the bottom half of the slab is going to be in tension. So we need to put our reinforcement in the bottom half of the slab. All right, not right on the bottom because we have to allow for our cover, and not right to the ends again for cover, but in the bottom half of the slab. Now, as I said before, this is where structural engineers make their money, because there's going to be lots of different situations where we're going to have different loads and different scenarios. So in this instance, such as a cantilever, we've got a load down in the middle, and again, we're going to have the self-weight of the slab plus anything else we're going to put out here on this end of the slab, causing a load out here. So there's actually going to be a bend over that support and a bend in here as well. So this is where our structural engineers can advise us where to place our steel and what size it needs to be. So hopefully that shows you the relationship between the concrete and the reinforcement in a reinforced concrete member, and that we are using the best properties of both materials to form a highly efficient.
So here, basically this is simply supported. As you know, bending moment or tension zone is here. That's why we'll provide at the bottom. At cantilever, we'll provide the top. This is also one of the important point, and we'll see some more topics in the next class, next video. Thank you.